In this video, we'll compare Istio and Linkerd Kubernetes service meshes. We'll run a couple of tests, which I'll explain later. First, we'll measure latency for each request from the client side. Then, we'll measure only the CPU usage of the sidecars. Istio uses Envoy, which is based on C++, to proxy each request. Linkerd initially used Envoy as well, but later dropped it in favor of homegrown proxy based on Rust programming language. So, in this video, we'll see if the Linkerd decision was correct. We'll also measure the requests per second made to our services. Well, first of all, how does a service mesh work? Let's say you have a client also deployed in Kubernetes that needs to access another application running in the cluster. It's not going to make a direct call. The request will be intercepted by the sidecar running in the same pod, and then it will forward it to another sidecar. Only then the request reaches that destination. Since the request is routed using sidecars, we can now implement dynamic routing, circuit breaking, and much more. Also, most service meshes, including Linkerd and Istio, automatically encrypt traffic using mutual TLS. The Go client exposes Prometheus metrics that measure latency, and we scrape C-advisors to get CPU usage from the sidecars. I'll run this test on my home lab, which is based on AMD EPYC processor. I built it using VMware Hypervisor. As you can see, I have a single Kubernetes control plane node and 5 worker nodes. During the test, I use affinity and tolerations to spread all applications across their dedicated nodes to avoid any interference. Now, in the first test, we'll run 2 clients and 2 applications in parallel for about 15 minutes. For the second test, when the client sends the request to service A, it will forward it to service B, then service B will return the response to service A and then back to the client. In this case, we have 3 sidecars intercepting the request, which should make it more obvious whether Envoy or Linkerd proxy is more efficient, not only in terms of CPU usage but also latency, which is even more important. This is because if you have hundreds of microservices, each sidecar will add latency. Now, if you want to reproduce this setup, I have a Terraform code that uses Helm charts to install both Linkerd and Istio service meshes. The link will be in description. I also have a client written in Go that exposes Prometheus metrics, which we scrape using Prometheus operator. You can find this as well in the code. To inject sidecar, you can use namespace labels. My preferred approach, however, is to inject sidecars into individual pods using annotations, such as this for Linkerd. By default, Linkerd does not set resource block on the sidecar, so we need to manually set requests and limits. The same applies to Istio. We can use labels to inject the sidecar and annotations to set the same requests and limits on the sidecar. To run the tests, I use jobs and specify the targets under the command section. So here we'll send 1 parallel request up to 1000 and scale up each second. Time to run the first test. In the idle state, you can see that the Istio proxy, which is Envoy, consumes slightly more CPU than the Linkerd proxy. As a reminder, I don't measure the CPU usage of the app container itself, only the sidecars with proxies. When I start the test, we'll also see a couple more sidecars from the client side, as I showed you in the diagram. On the top left, you'll see the requests per second measured for each service, Istio and Linkerd. On the top right side, we have a latency measured in percentiles. Here we have P99, which means that 99% of all requests sent to the application completed within that duration. Typically, we measure P50, P90, and P99. While we run this test, you can notice that CPU usage of Istio sidecars is significantly more than that of Linkerd. Pretty much the same pattern can be seen in the latency graph. Latency for the Istio service mesh is a little bit higher than Linkerd. Also, keep in mind that since both Istio and Linkerd meshes uses mutual TLS, sidecars need to encrypt and decrypt every single request. Now, let's wait until the end of this test and I'll show you the final results. Alright, this is entire latency graph. The blue one is for Istio and the red one is for Linkerd. As the load increases, we can see that the differences increase as well. I think it's partially due to the higher CPU usage of the envoy. So if you keep CPU usage low, you're fine in both cases. Now for the CPU usage of the sidecars, the top two lines for the Istio sidecars and the bottom two are for Linkerd client and the app. Alright, those are the results for the first test. Next, let's run a second test and add additional microservices to each mesh. Same layout, we have the requests per second, latency and CPU usage. Now we have two more sidecars as you can see in the graph. Let's wait 10 more seconds. Now, while adding more sidecars, the latency is now significantly larger, almost 2 times larger. So if you have hundreds of microservices and you want to keep latency as low as possible, you may want to consider Linkerd. I know that Istio has a larger community and perhaps more features, but you need to decide based on your use case. Now, the same goes for the CPU usage. The Istio proxy has significantly more CPU usage. If you're interested in benchmarks, I have a bunch of them on my channel. I'll include links in the description as well in the first comment. Thank you for watching and I'll see you in the next video.